Okay, first question here. Determine whether each of the following trigonometric graph is a sine, cosine, or tangent graph. You get ready with a pencil and a piece of paper because later on I will want you to sketch the graph. Okay, first one, A here. How do I determine whether it's what graph? You have to draw all the graph out. So over here, I've shown you already the simple sketches of the graph. What graph is this? This one, what graph is this?
Sine.
Sine, correct. What about this?
Cosine.
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 This one?
Tangent.
Okay, thank you. So if it's very hard for you to remember where is the x-intercept, where is the y-intercept, what you do is after you draw out three graphs, then you go and compare which one cut through 90 degree like this. So this one doesn't cut through 90 degree, it's not sine. This one cut through 90 degree, yes, but then this one also doesn't go through 90 degrees. So for sure, it's this part, half of the cosine graph over here is a cosine graph. That is how we determine it. Same with tangent graph, you see, okay, it goes through the x-intercept at 180. So this is one of it, and also this is one of it. But then you look at the flow of the graph, this one is from left to the right like this one is from right to the left. So this one is the tangent graph. And the last one, from 180 to 360 is a curve down here. So 180 to 360 is a sine graph. Okay, that is how you determine it. Question number 2, A, they ask you to sketch a graph for y equal to sine x, where the x is in between 90 and 270 degree. So you just refer to the original graph that you have for sine from 90 degree to 270 degree is right here, 90 to 270 degrees. So this is what you need to draw. So just follow everything with the x-axis and y-axis, 0 and 90 degree, 180 over here. You just draw this out. Okay, and then for the next question there, it's the same thing. They ask you to draw cos x, where it is in between 45 and 225. So if you refer to this graph here, 45 degrees start from here. 225 is in between 180 and 270 is here. So you need to draw this part. Okay, so make sure you don't start with 1 because you can see from here, this part is less than 1. So make sure you start with something like 0.75 and then it finish at this part over here also is about 0.75. Okay, sorry, this part here. So you should have something like this. Okay, you don't have to worry it have to be precise or not. You just, because it's just a sketch. So just roughly only on the value. Are you okay, class?
Okay.
Okay. Okay, now we look at question number 3 here. The diagram on the right shows 3 trigonometric graphs for angles between 0 and 90 degree. Okay, so you have to refer from 0 to 90 degree over there, which graph are there. Okay, for the first one, identify the equation for graph 1, 2, and 3. So this is graph 1. The pink one is graph 2, and the purple one is graph 3. So for graph 1 is going up for sure. The first graph here is y equal to tangent x. So y equal to 10x. Okay, and then this is graph 2 is going up like this. You can see it will form up a letter S. So graph 2 is y equal to sine x. And the last one, it could start from number 1 here. So when it start from 1, for sure the y is cos x. Okay, you can identify, right? Now, B, set the maximum value and minimum value of graph 1, 2, 3, if any. Meanings, over here, you have to refer to this graph and then you set the value of the maximum and minimum. So graph 1, this one over here, tangent is going up. So we don't have any maximum value because previously you already noticed the maximum value is infinity. Okay, it's undefined. Therefore, there's no maximum value. Same with the minimum value. There's no minimum. There is minimum value. The minimum value, it cuts through the y-intercept here. It is the 0. Okay, then graph 2. Graph 2 is the sine graph here. The maximum value is 1. you refer to this, the highest peak of the graph. And then the minimum value is 0. Graph 3, so this is graph 3. Okay, the one that cuts through the y-intercept, the maximum value is 1. The minimum value, you refer to this one, is 0. Okay, that's why I have this. Up to you how you want to write down your answer. For me, it's easier for me to write down in the form of table. That's why I write it down in table. Okay, number 4. For each of the following trigonometric functions, set the value of x when the value of y is maximum and set the maximum value. So they are requiring for the value of x when the y is maximum and the maximum value. So for y equal to sine x, that is in between 0 to 360, yeah, all of this. For y equal to sine x, the value of x when the y is maximum. So what is the value of x when y is at maximum? The value of x will be 90 degree. If you still remember the graph, it looks like the S, right? Something like this. So it's maximum here. The angle is 90 degree. Okay, and the maximum value, of course, is a 1. So we have 90 degree and a 1. And then for cos x, okay, what is the value when y is maximum? So when y is maximum, what is the value of x? So you remember your cos x, something like this, huh? So over here, when the y is maximum, the value is 0. You can see the 0 degree here. Okay, 0. And over this part, it will be 360 degree. That's why we have a 0 and 360 degree. Okay, how much is the maximum value? The maximum value is 1. Okay, and then for y equal to 10x, so what is the value of x when the y is maximum? So you remember for 10x, what is the value of y when x is maximum? It's like this, right? It's going up. So when the y is maximum going up. We don't know what is it. So there's no maximum value at all. Okay, and then what is the maximum value? Also no maximum value. Okay, so continue with question number 5 here. For each of the diagram below shows part of a graph of trigonometric function such that is in between 0 to 360, set the function and the value of m. So you have to set what function is this and what is the value over here. Okay, so how do we do it? You just need to compare to the 3 graphs that you have learned. Sine graph, cosine graph, tangent graph. Okay, so this one is going up like that, cut through m. So you can see over here, there's none of it like that unless this part here. Okay, so we notice it might be this one, and then we look at the second one. We need to compare. This one we can see the pattern over here, right? This part here, make it thicker. This one, it could be this one, it could be this one, and then this one, it doesn't look the same. So it could be these 2 only. Now, they ask you to determine the m over here. One is m plus 90 and one is m minus 90. Okay, which one look more accurate? This one look more accurate. Because you can determine the m is 270. When you add up with 90, it becomes 360. When you minus 90, it is 180. So this graph is the cosine graph. Okay, furthermore, you can see the range is in between 0 to 360 only. Okay, this one. Therefore, we cannot choose this one unless the range is in between 270 to 300, 420, 60, 60, 90, sorry, 450. Okay, 270 to 450. Then you are going to choose this one. Okay, now look at B. B is something like this. Okay, a mountain. So if you refer to this, there's no mountain over here for the angle between 0 to 360. We only have the mountain for the sine graph. Okay, so the value of m is 90. Okay, this is how we get the answer. Sine graph, and then the value of m is 90. Okay, class? Any question?
No question.
Now you can repeat. Okay, so today we are going to look at the effect of changes in constant a, b, and c on the graph of trigonometric function. Y equal to a sine bx plus c, y equal to a cos bx plus c, and y equal to a tan bx plus c. Previously, the basic one that you learned is y equal to sine x, y equal to cos x, and y equal to tan x only. So today they are adding up this part here, these three, sorry. Okay, a sine bx plus c. So a, b, c is add on. What are all of those? You can refer to this graph given over here. Okay, before I enter into the ABC later on using the GeoGebra sketchpad over there. So you need to know this part from the center line, we call this the center line of the graph. Okay, from the center line to the top of the peak of your graph over there, we call it amplitude. Same with the one here at the bottom. Okay, this is 1 amplitude, 2 amplitude, 3 amplitude, 4 amplitude. Okay, now the next thing, when you have a complete graph, this is a sine graph, right? When you have a complete graph like this, we call it a period. Okay, same thing when you have a cos graph is from here to here. So this part is also a period. Same goes with the tangent graph. Tangent graph is half of it, okay? But you don't have to worry. We are going to enter into that later on. We will see what does that mean. Okay, so let's look at the difference when A, B, and C, there will be value applied to the graph. Okay, this is the one here. Okay, we are going to look at the sine graph first. Start from A equal to 1, B equal to 1, and C equal to 0. Because the normal one that you learned previously is Y equal to sine X. So it will look like this. Can you see? Start from 0 to 360 over here is a complete graph. Okay, it looks like the S. So just carry on like that. Now, if I make changes to the value of A, you see, there's number 1 over here, right? When I change the A to 2, what is happening to the graph? What happened to the graph? It is still a complete graph. Yes, the amplitude is increasing. Originally, when the value is sine x only, whereby it means it is the 1, right? So it will fall on 1, the highest peak. But then when I increase the A to 2, okay, become 2 sine x, it will increase to 2. Same with the bottom part, it will be negative 2. Okay, that is the difference, meaning the changes of A will change on the amplitude. Okay, if I move to 3, you can see the difference. It moved up already, we cannot see. Now, if I lower down it to 0.5, so you can see what happened to the y-axis. Okay, 0.5, can you see? It's half of the 1. Okay, so A is the amplitude of the graph. Okay, now, if I change the value of B, I go back to 1, because 1 is the easiest one to compare. So the B is 1. The B is 1, it will look like this. Now I change the B to 2. Can you see the difference? Okay.
Yes.
How many period do we have from 0 to 360? How many period do we have? Hopefully you still remember period. Period means a complete graph. A complete graph is a complete S, right? You see? A complete S until 180. And then we have another one until 260. So there are 2 periods involved. Okay? Means the value of B over here will indicate how many periods in that whole turn for the graph. For 360. If it is 2, you will have 2 periods. Okay, you see what happened if I change to 3, When I change to 3, from 0 to 360, how many periods do we have? Did you notice? This is 1 period. This is 2 period. Yes, we will have 3 period. Okay, so B indicating the number of period. Okay, now I'll go back to 1. We look at the difference when the C change. Stop. Okay. Hold on, I attach my keyboard. Okay. So now is the original one. Now what happened to C? C is easy. When I move to 1, can you see what happened? The whole graph is shift up 1 unit. Okay, which means the original one, the maximum value is at 1, right? Now the maximum value becomes 2. And then down here, the maximum value originally is -1. It moves up, becomes 0. They shift the whole graph up. Again, I show it to you one more time. When it becomes 0, okay, you see, when it is 0, it's like this. Minimum value -1, maximum value is 1. So when I change the value of the C becomes 1, they shift the whole graph up. Okay, becomes 2 and 0. If I move it to -1, so it will go down, become 0 and -2. That's the minimum value, maximum value and minimum value. Are you okay?
Yes.
Yes, So for sine, cosine, now we look at cosine. Sine and cosine is still simple. The only different thing for the tangent is you have to see that the only one is a bit different. Okay, I move it back, everything becomes the normal one, y equal to cosine. So this is y equal to cosine, whereby the A is 1, B is 1, C is 0. So cosine, this is what you have, right? The maximum value is 1, and then it goes down like a U shape up to 360. We get another maximum value. Minimum, -1. So 1 period is this complete U. Now, still remember when I change the A, what will happen? A indicate what?
Amplitude.
Amplitude.
Very good. A indicate the amplitude, meaning the amplitude over here will change. Originally, now it's 1. So if I move it to 2, you see what happened. You see the amplitude becomes 2 and -2. Okay, so you just remember A represent the amplitude. Now I move it back to 1, the original. So B, what happened to B? What is the B represent?
Period. How many period?
Very good. B represent period. So now we only have 1 complete U, right? So if I move it to 2, you can see how many complete period do I have? From 0 to 360. 0 to 360, from here to here.
2.
2, right? Okay, this is 1 period. This is 2 period, up to 360 here. Okay, so this one is easy. Now, I move it back to 1. What happened to the C? Remember C, what happened? C represent the?
Maximum and minimum value.
Very good. It represents the maximum and minimum. So right now it's 1 and -1. So when I change it to 2, it will move up. Everything will move up. Okay, can't see the 2. Never mind. We look at okay, C equal to 1 here. So it will move 1 unit up. So maximum value originally is 1, becomes 2. And then -1 becomes 0 here. Okay, right? So these 2 graphs done. I assume you understand. Anybody that doesn't understand the movement of A, B, and C? A represent the amplitude, B represent the period, and C represent how much the graph is shifted up and down. So you can see the difference of the maximum and minimum value. Okay, the only different thing is for tangent. You see the tangent. I move everything back to the normal one. The normal one, C is equal to 0, A1, B1. So we have Y equal to 10x right now. This is the normal one that we see. Okay, so previously we start looking from the angle over here, 0, it moves up. Okay, and then this one, no maximum value. From 180, a shape like this. from T360 a shape like this. Okay, so this is this part now, from this part 360 up to 0. This is not complete. This is twice the period already. Okay, because for a complete period of a tangent is different from sine and cosine. Sine and cosine for a complete period, it is from 0 to 360 degree. But for tangent, a complete period is from 0 to 180 degree only. So it is from here up to 180 only. So a complete period, you will see this graph with this one only. Okay, now A represent the what again? Amplitude, right?
Yes.
So remember?
Yes.
Now we see what happened when I change the A to 2. When I change to 3, you see, it's getting what? It becomes what?
Straight.
Straighter.
It becomes a straight line, right? Actually, originally we have curve, which look quite nice. But then when I move it, it becomes a straight line. What if I move it to the left? The maximum that we can move is only this 0. It looks weird, right? So we call this the curvature changes. The curve of the graph. So we call it the curvature. C-U-R-V-A-T-U-R-E. The curvature of the graph change. Okay, so I move it back to the original one, which is 1. Now we look at the changes of B. For sine and cosine, if I change the B, the period change, remember? So 1 period for tangent is from 0 degree to how much?
180.
Yes, 180. Okay, so we look at B over here. If I change it to 2. Okay. Did you notice when I change it to 2, how many periods from 0 to 180 degree?
2.
2, right?
2.
Yeah, this is 1. This one is 2, another one. So from 0 to 180, we have 2 periods of tangent graph. Okay, now if I change the value of C, C is the maximum and minimum value, right? So for tangent, do you think there will be changes on maximum and minimum value?
No.
No.
Still undefined.
Yeah, but then you see the difference, how the graph is shifted up. Okay, when the C becomes 1. It shifts up. Now, originally from 0, right? The curve is like this, from 0. Now, when I change the C to 1, the graph goes up 1 unit. Okay, let you see one more time. Originally, it starts from 0. Same with this part here. How come it's not? Okay, the B is different. Okay, so it starts from 0 and then it starts from 180. That is the original one. When I move the C, change it becomes 1, it shifts up, start from 1, and then this one is in between 90 and 180. That's the curve. Okay, when I move it to 2, you can see the y-intercept becomes 2 over there. Okay, then this part, the tangent one is a bit harder for you to draw. It's closer to 90 degree already. Okay, when I move it to -1, so we will start the curve from -1. So you got to imagine one like this and then one in between 180 and 270 already. It shifted to the right. Okay? So this one you have to bear in mind, for tangent is a bit different. When I change the B, the curve will be like this. Okay, that is the number of period. When I change the A, sorry, B represent the period. When I change the A, the curve change. So the curvature changes. Okay. So I move it back to the original one. I need you to see this because there will be question regarding this later on. Okay, the B is 1, the A. So originally is from 0 to 180. We have one complete period. Now if I change the A, becomes further like this. Wait. I make it original one of it. I change the B, sorry. The B becomes 0.5. You see, this one is the original one. If I change the B becomes 0.5, what will happen? Can you see? When it's 0.5, the period, remember, it is 180, right? So right now, the period is from 360. You see the graph? The period, the complete period, is start from 360. When I move it to 1, it start from, it's in between 0 to 180. We have a complete graph. When I move it to 0.5, the complete graph range from 0 to 360 degree. Okay, now don't worry about it. I'm going to move back. Hopefully you understand the graph. I'm going to move back on the theoretical part. Okay, this is the theoretical part. Just this one later on. From what we see of the graph just now, when A changes, the maximum and minimum value change. Okay, and then B, when B changes, the graph will be compressed or expanded. So you can see the word like compressed or expanded. When it is compressed, the number of period increase. When it is expanded, the number of period decrease. C, when C changes, the graph will move vertically up or down. Okay, so the value of A affects the amplitude of the function. So A over here, when the amplitude is increasing, the maximum value will increase. And then the value of B affects the period of the function, and the value of C affects the position of the graph of the function. Okay, now this part here, amplitude can also be determined by the formula maximum value minus the minimum value and then divide by 2. What does it mean? Like this. If I have the amplitude, this is a 1. This part over here is a 1. This is a 1. This is a negative 1. What does it mean over here? It can be also be determined when you add up both of it. Sorry, not add up. 1 minus negative 1 becomes 1 plus 1, and then you divide by 2. So 1 plus 1 divided by 2 is a 1. That's why you can see the amplitude is a 1 over here. Okay, so that is the formula of the meaning over here. Amplitude can also be determined by the formula of the maximum value minus the minimum value, and you divide by 2. Okay, you just need to find the difference in between these two, and then you divide by 2, so you get the amplitude. Okay, now we move on. So this is the important part that we need to know. It's in your book, page 188. Okay, when y equal to a sine x bx, when a sine bx plus c, okay, the value of a is greater than 0, b is greater than 0, meaning that it's greater than 1 over here. So when the value of a changes, maximum and minimum value change. The amplitude of function is equal to a. Okay, whereas for y equal to a tan bx plus c, the graph curvature changes. Okay, the shape of the graph change. Okay, hopefully you still remember just now when I drag it to the back, it becomes a straight line. Okay, and then there's no amplitude for tangent graph. Now, for this both graph, when the value of b changes, the period of the function change. When the value of b increases, the graph appears to compress horizontally. The period of the function decreases. Okay, now the third one. This is for calculation. This part is important. The period of sine and cosine function is 360 divided by the b. Okay, divide by this b over here if you want to find out the number of period. And then for tangent is 180 divided by b. So that is the different thing for tangent. You got to remember this. Tangent is 180, but then for sine and cosine is 360. Now, if you look at C, when the value of C changes, the position of the graph change. So when the C is greater than 0, the graph moves C units vertically up the x-axis. And when it is less than 0, it moves C units vertically down the x-axis. Okay, that is roughly the meaning. The most important part is still the B. Okay, now we look at the question given. Example 9. Are you okay, class?
Okay.
Yes.
Okay, we look at example 9. I'm going to go fast right now. The diagram on the right shows the graph of function y equal to sine x. So this is y equal to sine x for in between 0 to 360 degree. Do you all know how to draw the graph of sine x, cos x, and tangent x now? If I simply ask you to sketch, can you sketch one out right now? Can or not?
Yes.
Yes, okay, get a piece of paper, everyone. Get a piece of paper. I want you to sketch without looking at the question here. Sketch a graph of cosine x. Y equal to cosine x, and then show it to me. With all the important maximum value and minimum value. Okay, go back to this. So this is sine x looks like. Okay, now sketch each of the following trigonometric functions on the same axis for a, y equal to 2 sine x. So you know when it is 2 sine x, what will be changed? The period, right? Sorry, not the period. The a over here, the maximum and minimum value will change. Okay, so over here we will see it goes to 2. And then this one also goes to -2 and reach 360. So the pink one is the original one. Okay, when you draw the graph, it's up to you. You can draw out the original one as a guidance so that you can draw the correct answer. If directly you know the correct answer, you want to draw the answer directly, yes, you can go ahead. So this is y equal to 2 sine x. Okay, now this one is simple. So I move to the second one, B. Y equal to sine 2x. Meaning the amplitude doesn't change right now, but then 2x over here, so the period will change. Okay, if it is 1x, meaning it's from 0 to 360. So when it becomes 2x, meaning it will be how many period in that 360 degree? There will be 2 period, correct. So how do we do that? They show you the working even so that you know how to do that. The original one is the one in pink. So when it becomes sine 2x, so from 0 to 180, there will be one complete period. And then from 180 to 360, another period. So when the b is equal to 2, the period becomes 360 divided by 2 equal to 180. Means from 0 to 180 here, you will have one complete period. So you will have from 0 to 180 again, at the back, you will have another complete period. Okay, now we look at question C. Question C is y equal to sine x plus 1. So when it is sine x plus 1, the only changes is on C. Okay, the movement of the graph. So originally, it's the one in pink. You just shift the whole thing up 1 unit because it's plus 1 over here. If plus 2, then you have to shift up to 2. So 1 here, and then it falls on 0. It doesn't fall on -1 because you shift the whole thing up. So the maximum, not the maximum, it starts from 1 here, and then it falls on the minimum value of 0, and then move up. Okay, and then for D, they ask you to draw y equal to 2 sine 2x. So the value of the A indicate the amplitude. So you can see it moves to 2 here. And then the 2 over here indicate the number of period. So 360 divided by 2, 180 is 1 period. So from 0 to 180, we have a complete 1 period. Okay, 180 to 360, another complete period. So that is the meaning over here. If the question asks you to draw from 0 to 360, then you have to draw like this. If the question asks you to draw from 0 to 180, then you just have to draw this part only. So for this question, they ask you to draw to sketch the graph from 0 to 180, to 360. That's why you have to draw the whole thing out. Are you okay with example 9?
Yes.
Yes, huh? Okay, we move to example 10. It's going to be faster right now. Sketch each of the following trigonometric function for 0 to 360 degree. Okay, 0 to 360, a whole turn. Huh? Now, y equal to 2 cos x plus 1. So first, before you look at this, I'm going to look at y equal to 2 cos. Cos originally, so we have a 1 here. Something like this, huh? This is a 1, this is a negative 1. Okay, now when it moves to 2, so you have a 2 up here, so you have something like this. Okay, roughly only, huh? Then, now, when they plus 1, the plus 1 over here, what does it mean? You are going to move another what? Another 1 unit vertically up the x-axis. So you can see from 2, you add 1. It becomes 3 here. Okay? So just now, oh, my graph not correct. It should be 4 to 2. Sorry, huh? Because there is a 2 here. So it should be 2 and 2 here. Negative 2. 2 and 2, huh? So when plus 1, this one is going to move up. The 2 becomes 3. It moves up 1 unit. So the negative, it moves up 1 unit becomes what? Negative 2 move up 1 unit becomes?
Negative 1.
Negative 1.
Negative 1. That's why you have this 3 here with negative 1 here for the minimum value. So this is how your graph look like. Okay? Sometimes you can't directly draw the graph, so you have to go through a few steps. You have to sketch your own first, only then you can draw the last one out. So are you okay with y equal to 2 cos x plus 1?
Okay.
Yeah.
Madam.
When you draw the graph, you don't have to show all this. You don't have to show the one in blue color. You just need to show your y-intercept and x-intercept correctly like this. Okay, now I move to the second question here. Y equal to 10, 0.5 x minus 1. Okay, so that's why I said the 10 is a bit harder to draw. So the original one that we learned is y equal to 10x. Now they add on 0.5. Remember, when the value of b changed for 10, one whole period is from 0 to how many degree? 0 to how many degree?
180.
Very good, 180. So 180 divided by 0.5. We are going to get the period, 1 period. So it's equal to how many degree? 180 divided by 0.5 means 180 times 2, right? So the answer is 360. Okay, meanings for this graph from 0 to 360 later on, there is only 1 period. Okay, originally this one is 0 to 180 degree. You have 1 complete period. But now from 0 to 360 degree, only then you will have 1 complete period. Okay, so for the 10, it will look something like this. From 0 to 360 degree. So this is 0, this is 90, 180, 270, 360. This is the x, this is the y. Okay, so you will have a complete line like something like this. But the curvature will also change. So I need to draw it further. The curvature will change. Something like this. Okay, originally, hopefully you still remember when it is 0, 90, 180. Originally, it is like this, right? So this one 360 right now, you have this. Okay, now the next thing, -1. -1 indicate that the graph going up or down. Going up or down?
Down.
Down, right?
Down.
You can see when it goes down, everything have to move 1 unit down. So this line over here, you have to move 1 unit down, becomes somewhere here at -1. This one also, you have to move 1 unit down, become somewhere here, and then you draw it. So you will see this graph given. It becomes -1, and then this one, it moves down somewhere here. Okay, you got to remember the curvature change. It doesn't look like the original one in between 90 to 180. The maximum, it doesn't reach 90. The maximum here, it doesn't reach 90. But when you move, when the period change, so the maximum here, it doesn't reach 180. The maximum here, the minimum here, it doesn't reach 180 if I draw a straight line. Okay, so the curvature change. Are you okay, class?
Yes.
Okay, we are going to look at the last one. The last one is solve problem. So that one is example 11 in your book. Okay, we look at example 11. This is the one here. So how to apply it? So we are at the end of the chapter already. Now we look at the graph here. It shows the airflow of velocity in normal respiratory cycle. So this is the airflow. This is -0.6 to 0.6. So this part, inhale, exhale, time in seconds. Now we look at the given information here. The graph above shows a complete respiratory cycle. This cycle consists of the process of inhalation and exhalation. It occurs every 5 seconds. So inhale, exhale, 5 seconds. Airflow velocity is positive when we inhale and negative when we exhale. This velocity is measured in liter per second. Okay, so you can see the unit here, liter per second. If y represents the velocity of airflow after x second, okay, set a function in the form of y equal to sine bx plus c, which models the airflow in normal respiratory cycle shown as the graph above. So if you look at this part here, if y represents the velocity of the airflow after x second, so you have to set a function. Set a function. How do we set a function? From the graph, you can see the maximum here and the minimum. So this is a sine graph, right? Originally, y equal to sine x. So now from the value over here, it indicates the value of A, B, or C. This peak here, it indicates the value of A, B, or C, because just now you apply the value of A, B, and C to get the answer, right? So this one indicates what value here?
C.
No answer?
A.
It's A, right? You still remember the amplitude? Okay, so from the 0.6, we can form up the equation already. It is y equal to 0.6 sine x. But it's not done yet. That one is to indicate the amplitude. So we put it in front. Are you okay so far?
Yes.
Yes.
That's all. Now we need to look for the B. A is done. We need to look for the B. So to look for the B, this is a sine graph. When you want to look for the B, you look at the number of the time given. This is 5 seconds, right? So if you want to find out the period, how do we get the period? The B is going to be, it's original like this, 360 degree divided by B. Okay, we are going to get the value of 5 seconds. Do you remember just now we did some of the example before? We did the example before, like this one. This one cannot. This one. You're given the B. So to get the angle, So we are going to use 180 divided by the B. We get this 180 divided by B. We get the angle. Now, the problem solving question, you are given the answer at the back. So we are going to substitute into it. 360 divided by B equal to 5. You are given the angle first. Okay, now to get the B, it is equal to 360 divided by 5. So 360 divided by 5, you are going to get a 72. Yes. So from the graph that you have, you can continue already. The next equation will be y equal to 0.6 and the B is 72, right? So sine 72x. Okay, now if you look at the graph, do we have any C? Is there any movement up or down the graph?
No.
No, right? There's no movement up or down the x-axis over here, right? So meaning that the C is equal to 0. So we don't have to add any C at the back of the equation. Okay, therefore the answer is just y equal to 0.6 from here. Sine 72 because you divide it. Okay, and then you get a B. That is the answer for the equation. Are you okay, class?
Yes.
Yes.
Okay.
Okay, so the first one is done. We look at B now. What is the velocity of a floor in liter per second when the time is 7 seconds? So when the time is 7 seconds, from the equation, I rewrite. Y equal to 0.6 sine 72x. What is the velocity of a floor? So when the time is 7 seconds, the 7 seconds is represented by the x graph here, right? So you just have to substitute the 7 seconds into the x given. Okay, so it is equal to 0.6 sine 72 times 7. Are you okay?
Yes.
Yes, huh? Okay. Then lastly, you just need to press a calculator. Okay. Do you have a calculator with you?
Yes.
Yes.
That's all. Okay. Then you are going to press this. Everybody press together. 0.6 sine 72 times 7. So you just need to press 0.6 sine and then in bracket, or already have bracket, 72 times 7. Do you get the answer?
Yes.
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 So y is equal to 0.35. Because I didn't mention how many decimal places, and then for this type of question, you just need to mention 2 decimal places will do. If you want to put 4, also no problem. So it will be 352, let me see, 27, yeah, 27. So the velocity of a floor is equal to 0.3527 liter per second. You just need to re-answer the question because there is question given. Okay, the velocity of the air flow is 0.3527 liters per second. Okay, so that's all for the whole chapter. Any question? No questions?
No question.
No question.
No question, okay, good. So what you have to do is self-practice 6.2b and self-practice 6.2c.